In this video we are going to study about the directed graph, the terminology for directed graph. Okay, so you already know directed graph is a graph where edges are having directions. Okay, so terminology means we are going to study about in degree and out degree of a directed graph. So first of all we will see the definition. When v is an edge of graph G with directed edges where u is said to be adjacent to v and v is said to be adjacent from u. Okay, so if suppose there is an edge between two vertices u and v, so the direction is like this from u to v. Okay, so in this case it is said that u is adjacent to v and v is adjacent from u. So both of them are the neighbors and the direction is uv, and remember that this edge we can represent with sequence uv. Okay, you cannot represent it with the sequence vu. Okay, so this can be a wrong representation, so you can represent it uv, where u is called as initial vertex and v is called as terminal vertex, end vertex, or you can also call it as a sink. Okay, so in directed graph the last vertex is called as sink. So for this directed graph, as we already have seen for undirected graph, here also we have to find in degree and out degree. So in undirected graph we have only seen degree of a graph, not in degree and out degree. Okay, so here we will talk about the in degree and out degree of graph. So in a graph with directed edges, in degree of vertex v is the number of edges with v as a terminal vertex. Okay, so where the edge in which v is the terminal vertex means, suppose this is an edge for v, so v should be terminal vertex, that is all the edges should be coming towards v. Okay, so that is called as in degree of v. So here the in degree of v is 2 because there are two edges coming to the v. So in degree is denoted by degree minus v, means degree deg minus sign of v, that is the in degree of vertex v. Now out degree of vertex v is defined as number of edges with v as the initial vertex, means the number of edges which are starting from that particular node v. Now let's say there is a node or vertex v and you are starting from here to another vertex, let's say vertex z. Okay, so this is out degree of vertex v. So out degree of vertex v is 1. It is denoted by degree then plus sign of v. Okay, that is out degree. So if you consider this graph is a directed graph having 6 vertices. Okay, a b c d e and f. Okay, now we will see in degree and out degree of every vertex of directed graph. So consider vertex a. So vertex a, there are 2 incoming edges, right? So the in degree of vertex a is 2. Now at the same time the vertex a has how many outgoing edges? See, this is one outgoing edge, this is second outgoing edge, this is third outgoing edge, and this self loop is also outgoing edge. So it is having degree, out degree as 4. Now consider that the loop is counted in degree also and out degree also. So wherever there is a loop, that loop will be counted as incoming edge also and outgoing edge also. Now take the example of degree b. So for b there are how many edges coming to b? There are 2 edges coming to b. So in degree is 2, out degree is 1. Only one is outgoing. So take the example of c. In c there are how many edges coming? So this is first one is coming, second one is coming, and third this loop is coming. So in degree of c is 3 and out degree of c is 2. So out degree 2. So this is this one is out degree and this is loop is second one, that is the out degree. So out degree is 2. Okay, now the in degree for vertex D. So D vertex is here. So how many edges are coming towards vertex D? There are two, 1, 2. So D having two edges coming. So in degree of D is 2. How many edges are going outwards? There are 2. This is first one outwards, second one. So out degree is 2. Now in degree of this vertex E, for E, how many edges are coming? Calculate them. 1, 2 and 3. So 3 edges are coming. So in degree for this vertex E is 3. How many edges are going out? This loop is going out. So this is first one, this for out degree, this is second one for out degree, and this is third one is going out. So 3 edges are going out. So out degree is 3, right? So we have to represent this out degree with plus sign, right? So here there should be plus sign, right? Now say degree of in degree of vertex F. Now concentrate on this vertex F. So what is this vertex? Vertex F is not the part of the graph. Okay, so vertex X is not, sorry, vertex F is not the part of the graph. There is no in degree and no out degree. So in degree of vertex F is 0 and out degree of vertex F is 0. Okay, so this is the in degree and out degree of all the vertices of the graph. As we already have discussed in previous class, that the vertex which is not having any adjacent edge, we call it as a isolated vertex. Okay, so here we are having this vertex F which is not having any neighbor, so we call it as a isolated vertex. Okay, so isolated vertex has in degree and out degree 0. Now this chart was representing in degree, this was representing out degree. Okay, now add all the in degree. So if you add all the in degree of the graph of all vertices, 2 plus 2 4 plus 3 7 plus 2 9 plus 3 12. So here there are 12, summation of in degree is 12. Now add all the out degrees. So 4 plus 1 5 plus 2 7 plus 2 9 plus 3 12. So out degree also comes to be 12. So this is a theorem that for a graph where you find directed edges, so the sum of in degree and out degree is equal. For a graph where there are directed edges, if you compare the sum of in degrees of all vertices and out degree of all vertices, it comes equal. Now one more point, that even though this is 12, so means this 12 figure is equal to the edges of graph, and this sum is equal to total number of edges in the graph. So this graph will have 12 edges. So if you, now we will calculate the edges, how many edges are there in this graph. So there are 12 edges. So calculate the edges. So this is first, this is second, I am highlighting with red color, this is third edge, this is fourth, okay, this is fifth, then from B to D 6, from D to C 7, from D to E 8, from E to D 9, the loop at E is 10, so from E to A 11, from A to again E is 12. So how many edges are there? 12 edges. So number of in degrees is equal to number of out degrees is equal to number of edges in the graph. So this is the theorem. Okay, so the same thing has been described here. The sum of in degrees and sum of out degrees for all vertices in a graph with directed edges is same. So in our case it was 12. Both of these sums are number of edges in the graph. So in our graph there were 12 edges. So this proves this formula. Now one theorem, let G is a graph. So G is a graph with B vertices, E edges. So then there is a formula that summation of in degrees of all vertices and summation of out degree of all vertices is equal to number of edges in the graph. So you can see this is the formula that summation of in degrees and summation of out degrees is equal to the number of edges of the graph. So this is the theorem that we already have proved. So hope you understood the in degree and out degree for a directed graph. Thank you.